Okay, our objective for today, I can simplify exponential expressions with fractional exponents. Let's read together, 1, 2, 3. I can simplify exponential expressions with fractional exponents. So we're still on the same concept, and I asked you guys to set up your Cornell notes yesterday, right? So exponential expressions, they are numerical or variable expressions raised to a power greater than 1. That you should know. You should know your examples, and you should know your non-examples. So what is the critical attribute? Expressions only, and have exponents greater than 1. Okay? Steps. Write these down, please. Step 1. If the exponential expression has a fractional exponent, then rewrite as a radical and factor the number completely. Step 2. Identify the index of the radical to find the root. Step 3. Raise to the power outside the parentheses. And step 4. Simplify. I'll give you guys some time for that. Go. Okay, as you're finishing up the steps, I'm going to go ahead and clarify some terms. So check this out. Where you see the word radical, that term, I want you to put this symbol over it. Look up. Before you knew it as a square root, but from this point forward, since we're no longer going to be dealing with square roots, we're going to be dealing with cube roots, fourth roots, fifth roots, sixth roots, and so on and so forth. That's why we're going to call it a radical. Okay? For step 2, I want you to copy this. You're going to do a radical. You're going to put a little 3 outside, right there, right in the little angle right here. You're going to circle the word index, and you're going to point an arrow to the 3. Those of you that have colors, use colors. So from now on, we know that the symbol, this one is a radical, and this one is the index. So that when I'm asking you questions in regards to helping me with a problem, use the terms, please. I don't want you to just say, put the number outside the thingy. No. Put the index, or write the index outside the radical. Does that make sense? Also, if I write a number inside of the radical, such as 27, this is known as the radicand. So there's 3 terms that we need to understand. The number that's outside is called the index. The symbol here is called the radical, and the number inside is called a radicand. Are we there so far? Okay. So what does that mean? What it means is this. In the past, look up to the screen, we used to do this, square root of 16. What did that mean? What number times itself gives us this number? So what was that number? 4. What other number? -4. Okay. These are known as square roots, or in other words, roots. Why square? Because check this out. If we look up to the screen, 16 comes from the area of a square. To get the area of a square, how many dimensions do we need? 2. Therefore, how many numbers multiply times itself here? 2. That's why it's that number. 2 dimensions. And do you see where they got the symbol from? If we look up. You guys see it? You don't see it? Because it's talking about 2 dimensions here. However, look at this one. 3. What is another word that we use for this 3? Cube. So cube, what does that sound like? Does that look like a cube? Let's say the volume of this cube is 27. So what number times itself, how many dimensions do we have? 1, 2, and 3. So what number times itself 3 times gives me that number. Close? 3 times 3 times 3 gives me that. This index is going to indicate how many times we multiply that number by itself to get the number inside, which is the radicand. Are we there? All right, let's move on. Yesterday, on Monday, I introduced, when we did the prime factorization, I said prime numbers and composite numbers. And I said prime numbers are numbers with factors 1 and itself. So my prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. So let's see, what do I mean by that? What factors, if I multiply them, give me 2? 1 times 2. How about 3? 1 times 3. 5, 1 times 5. 13, 1 times 13, and so on. So notice that we only have 2 numbers, 1 and itself, yes? How about this one? What factors multiplied give me 4? 1 times 4, and what else? 2 times 2. So notice this one does not fit in here because it doesn't only have factors 1 in itself, it has the other factors, 2 times 2. This is what we call a composite number. Composite number has other factors other than 1 in itself. So let's say 4, 6, 8, 9. You're like, 9? Yes, 9. 1 times 9 and 3 times 3. That's why it's a composite. Remember that? All right. Also yesterday I said prime factorization. I said find me the prime factors of 32, and I said always start with the first 5 prime. 2, 3, 5, 7, and 11. Which one of these divides into 32? That's 2. Circle that. Gives us 16. Again, 2. Circle that. Gives us 8. 2. Circle that. Gives us 4. 2 and 2. So these are called prime numbers, but when you write them as a multiplication, they're called prime factors. Another way of writing this is 2 to the 5th. So far so good? Okay. So, in the back, write example Q. Example Q. I want you to write x to the 1/2. Underneath that, x to the 1/3. Underneath that, x to the 1/4. Underneath that, x to the 1/5. Dot, 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 x to the 1/23. Okay? Pens down, pencils down. So this is the definition that you should have watched yesterday and used it for the homework, right? Here it goes. From now on, whenever you see a variable or a number to the 1/2, the base is the radicand, and then you write a radical, and the denominator is the index. Except for on this one, we don't write the 2 because we already know that a square root has how many roots? 2. Therefore, this one becomes cube root of x. This one becomes 4th root of x. This one becomes, tell your neighbor, 5th root of x. Copy that and do the last one, please. Okay, so for this one, you should have written what? 23rd root of x. Hence, you got that. Okay? So, now, how does this look with numbers? Okay? Draw a line down like this. I'm going to use numbers. 9 to the 1/2. So, before I write that, look up. Who notices that all of these have indexes? You can see them. Which is the only one that does not have an index? the first one, right? Because we already know from K7 that this is square root. Squared talks about 2 dimensions. So whenever we do square roots, we know that there's an invisible 2 right there. Does everyone understand that? Therefore, 1/2 of x became square root of x. 1/2 of 9 becomes what? 1/2 of x becomes square root of x. 1/2 of 9 becomes square root of 9. And what does that mean? It means what number times itself how many times? Twice, because there's an invisible 2. What number times itself gives us 9? 3. So this becomes 3. Are we there so far? Okay. Let's try another one. Let's do 27 to the 1/3. So 9 to the 1/2 became square root of 9. 27 to the 1/3 becomes what? Cube root of 27. And what does that mean? It means that it has to multiply times itself how many times? 3. What number times itself 3 times gives us 27? Yes. This is 3 times 3 times 3, so this is 3. How are you doing? Do this next one by yourself. I'm going to give you about 20 seconds. 16 to the 1/4. Let's see what you get. Go. Okay. The correct answer for this one was 2. This becomes 4th root of 16, which means it has to multiply times itself how many times? The index tells us 4 times. One number times itself 4 times gives me 16. Let's see. 1 times 1 times 1 times 1. No. 2 times 2 times 2 times 2 times 2. Yes. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So the answer is 2. Are we there so far? Okay. Try this next one. 125 to the 1/3. Go. 20 seconds. That is correct. 5. This becomes cube root of 125, which says cube root of what times what times what. 5 times 5 is 25, times 5 is 125, so the answer is 5. So far so good? Alright. Copy these, please. Example 1A, 343 to the 1/3, and B, 32 to the 1/5 plus 9 to the 1/2. Let's do A together. Here we go. What would be my first step? Tell your neighbor, please. Okay, Aithne, what did your neighbor say? Or what would be our first step? Aithne? We write this with a radical. Very good. This becomes cube root of 343. Hands if you got that. Okay. Next, this we need to find what number times itself 3 times gives me 343. Now you can start 1 times 1 times 1, 2 times 2 times 2, but let me give you a hint. Usually when we factor these out, we usually get a prime number. Therefore, have these handy. 2, 3, 5, 7, 11. Most of the times when we decompose a number to find its root, it has to be one of these, most of the time. So could it be 2 times 2 times 2? 3 times 3 times 3? 5 times 5 times 5? 7 times 7 times 7? Yes. So the answer is 7. Another way of looking at this is like this. That's why the other day I gave you guys practice to do the factor tree. Which of these can divide into this? Let's see, 7. Let me see if that works. How many times does 7 fit into 34? 4, that is correct. Let's see, 4 times 10 is 28. How many more to 34? 28, 29, 30, 6. I bring the 3 up. How many times does 7 fit into 63? 9. I circle the 7. This one becomes 7 times 7. So these are 7 times 7 times 7. That's how we get these. You cannot do it either way. Start thinking out loud to yourself or in your noodle to get them like this, or do the factor tree. And which primes are going to use? 2, 3, 5, 7, 11, maybe 13. Okay? So with that said, see if you can do this one by yourself. B, go. Okay, let's see. I heard everyone say that this is equal to 5. Let's find out. This one says 5th root of 32, which means we want to find out the 5th root of a number times itself. How many times? 5 times. 1, 2, 3, 4, 5. And you can do it like that, or you can do the factor tree, right? Let's see, I'm going to try and do the guess and check. 1 times 1 times 1 times 1 times 1 is 1. No. 2 times 2 times 2 times 2 times 2. What is 2 times 2? 4 times 2. 8 times 2. 16 times 2. 32. Yes, it's 2, so therefore this is 2. Plus, this becomes square root of 9, which means what number times itself 2 times gives me 9. 3 times 3, therefore it's 3, so 2 plus 3, that is 5. That is correct. And for those of you that were here in tutoring, yesterday I went over this, and then I said open your book and do number 17. And then we did practice. But let's continue. Copy these. Do number 1A, 81 to the 1/4, and then B, start it off, and then I'm going to elaborate on this one. Go. Hands if you got 3. That is correct. This becomes 4th root of 81, which is 4th root of 3 times 3 times 3 times 3. Therefore, this is 3. Okay? Let's see. How about this one? Help me with this one. Brenda, what do I write? Square root. We don't write the 2 because it's invisible, but we write inside what? 121. What does that mean? Square root of 121. So, if you can't think of it, what did I say? Have handy the first 5 prime. 2, 3, 5, 7, or 11. Start thinking about which one of those times itself gives me 121. So, Brenda. She said 11. 11 times 11 is 121. Therefore, that's 11. Hands if you got that. Okay? Now, look at this one. I'm going to elaborate on the second one. Let me copy it first. Boom. Just like that. Pretty cool, huh? All right, here we go. This becomes 4th root of 256. Yes? For some numbers that are too big to start thinking, oh, and then going one by one, start with your factor tree. Check this out. I'm going to show you how to do this with a factor tree. Which one of these 5 will divide into an even number? 2. This becomes 128. What number divides into 128? It ends with an even number, so therefore it's 2. That becomes 64. 64 can be divided by 2. That is 32. 2, 16. 2, that is 8. 2, that is 4. And 2 times 2. Are we there so far? Okay. Now check this out. So therefore, I have 4th root of, how many 2's do we see? 1, 2, 3, 4, 5, 6, 7, 8. 2 times 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 2. Okay. So now, pens down. Look up, please. Miles, focus. Close that, please. Check this out. Look at this one. This one we said we're going to get the number out that repeats how many times? 4 times. There it is. So we extracted that. Here, it's an invisible 2, so which number repeated twice? 11. So here the question is, look up please, which number repeats 4 times? Which one? 2. Here it is, 4 times. 1, 2, 3, 4, so I extracted. There it is. But you're saying, wait a minute, but there's another set, Mr. Q. Yes, so then box that. If it repeats 4 times, you get that one out also. So now, what is 2 times 2? Therefore, this becomes 11 plus 4, which is 15. Copy that, please, so you can see that process. Okay. Now, like a side question, here we go. What if I had this? 4th root of 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. Think about it. What would that simplify to? Don't say it out loud. Take it to yourself. 4th root of 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. Carlos, what'd you get? Marilyn. Close. Yes. 6. Which number repeats 4 times? The 2. Okay. 2. We extract that. What other number? The 3. But we don't add these. They multiply. Aren't they multiplying inside? So what is 2 times 3? 6. That would be our root. Everybody there? Okay. So, any questions with these simple ones? Okay. So now check this out. In the video that I had you watch, I explained that there's 2 different ways of simplifying an exponential that has a fractional exponent that has a numerator greater than 1. Look at this one, has a 2, right? There's 2 different ways, but I'm going to focus on one way because I don't want to get you confused. So check this out. I'm going to take this. Look up, please, to the screen. The first thing is that I want you to understand that this 2/3 could be broken up. Okay? Check this out. Look up to the screen or you're going to miss it. 2/3 is the same as 1/3 times 2. Do you agree with that? If you don't see it, here it goes. Let me show you why. This could be written as 2/1. And if we multiply this times this, 1 times 2 is 2. 3 times 1 is 3. Therefore, 2/3 is the same as 1/3 times 2. Are we there so far? So what I'm saying is that whenever, because if you notice on the previous examples, we didn't have exponents where the numerator was greater than 1. Did you guys see that? But now we're going to start seeing those. So you need to understand this. Here it goes. The base I'm going to leave the same. So whenever you get to some of these, make sure you break up this fraction. This becomes 1/3 times 2. Is everybody following up to right there? Okay, pay attention, stop writing. Now, why did we do that? Because we already know how to do this, right? How can we write this? Cube root of what? B. Does everybody understand that? What symbol do you see here? Multiplication. Therefore, I'm going to indicate that with a parenthesis. What goes outside of the parentheses? 2. Copy that, please. Okay, now how does this look with numbers? Here, let me show you with numbers. Watch. I'm going to write this one this way, but with numbers. Watch. 27 to the 2/3. Just pay attention for this part. First of all, what did I do from here to here? I broke up the fraction. Is that correct? Yes. So basically, I'm going to write the 27 again. But this one's going to be what? 1/3 times 2. Are we there so far? Then I box this because I know what to do with this. This becomes what? Cube root of 27. What does this indicate? Multiplication, so I open a parenthesis, and what goes outside? The 2. Are we there so far? Now check this out. Cube root of 27. Now that we did plenty of practice, what is the cube root of 27? 3, because it's 3 times 3 times 3. Are we there? 3. Bring down the parentheses and the square. What is 3 squared? 9. Copy that, please. Okay, so let's see. You do this next one by yourself. 8 to the 2/3. See what you get. Go. 8 to the 2/3. Okay, Eric, help me with the first step. What do I write?
You write
8.
8. You put in a radical, or yeah.
You need to rewrite this first.
Oh, alright. So 8, and then you put a thingy, like an arrow, and then to the 2/3. The 2/3 times 2.
Okay. Yes, go. 1/3 times 2. Next. Yes.
And then you put cube root 8.
Cube root of 8 times to the 2nd power. This is 2 to the 2nd power, which is, hands if you got 4. That is correct. Tonight's homework is found on page 35, numbers 17 to 40. So basically, you're going to finish that page up today. Okay? Those of you that already did half, so you only have half for homework. Okay? This video I'm going to upload at the end of this lesson, so it should be up there on my channel. Go to 23 Mr. Q, click on the picture, and it should be the first video in there. Have a good one, guys. Enjoy your homework. See you guys. Tamales. Bah, do your homework.